This is the Amp Hour Podcast, released December 22nd, 2019. Episode 472. Keyzermas Vacation.
Welcome to the Amp Hour. I'm Dave Jones from the EEV blog.
And I'm Chris Campbell of Contextual Electronics.
And this is Jeff Keyser from Mighty Ohm.
Hey.
Hey, guys.
Merry Keyzermas. Merry Keyzermas.
Merry Keyzermas.
Oh, and yes, sir.
Yeah,
yes, sir.
I was waiting for it. I was going to give you the cue, but I thought that was a bit unprofessional, you know.
Yes, sir. We need like the little red button that when you push it, it goes, yes, sir. Could have the Keyzermas edition.
So Jeff, it hasn't been a year, I don't think. I think we've had you on because you and I traveled a bunch together this year.
Yeah, that's true. Well, we recorded a little mini episode during Teardown. I think that was the last time I was on the show. But yeah, did we do a bit during Chaos Camp?
No,
I can't remember.
We didn't do it then.
I think it was Teardown then. So that was June?
Right. Yep. Yeah. I mean, you and I and Peter kind of all traveled a bunch together this year. So it was nice. Dave, you got to join us next year.
I feel left out. Yeah.
You have a way to fix that, but it involves shipping containers, I think.
Right. And 40 hours on a plane.
Oh, I meant moving to the U.S. That's what I was getting at.
Okay.
Yeah.
Right. Oh, yeah, we're going to do that.
Yeah.
Sure.
Right. It's a bit drastic. So, Jeff, what has been new since, I guess, June? I mean, what's been on your radar?
Oh, let's see. Well, I've been traveling, as you know. Let's see. This year, I did a bunch of travel this year. So I went to CES in January. I went to DesignCon this year for the first time in a few years. That was back in January, so beginning of the year. Went to DesignCon down in San Jose. That was super cool. Really enjoyed that. And I think it was, for me, the confirmation of something that I'd suspected for a long time, which is that digital designers are becoming microwave designers. Because if you go to one of these conferences these days, it's all about crazy high-performance PCB materials and things like that. Connectors. Like, I've never seen so many SMA and associated connectors at like what is, I think, mostly a digital signal integrity conference.
Right.
And this has probably happened over the last 10 years, but like it had been maybe 5 or 6 years since I'd been to DesignCon. So it was kind of crazy just to see the disparity from one time that I went to the next. I went to the IEEE EMC symposium this year. That was in New Orleans, and that was in July. That was awesome. Not only because the conference was a lot of fun, but it was the first time that I'd ever been to New Orleans before, which is such a cool city. And I enjoyed that a lot. People told me it was going to be horrible because it was like August. It was, or late July. It was the hottest that it had been. Like it rained. There was a hurricane, all these things. And then I got there and it was incredible. Like I had a really, really good time and I'd love to go back. So that was one of the highlights of the year for me because I just loved being there. And it was one of the coolest cities in the U.S. that I've traveled to in quite a while. And then Chaos Camp, we mentioned Teardown. Super Conference was just in November, and now I'm back home again. So it's been a busy year of travel for me, and I've had a really, really great time going to some events that I'd not been to in a few years, like SuperCon, which I think I'd last been to in 2016.
Can you update us on your employment status?
I am fully employed for myself.
No longer at Valve?
No, I've no longer at Valve since
earlier this year. That's
year.
Right, you were just... you're on the way.
That's
out.
right. Yeah. So I haven't been with Valve since February. I was a contractor for about a year, a little bit less than a year, from like mid 2018 through February of this year. And since February, I've been making kits. The Geiger counter kit is still like a big thing for me, and I've been spending quite a bit of time, mostly during the first half of the year. I'd been working with a new distributor. I'm sure I mentioned this on the last show, but I worked with Elector to bring Geiger kits to Europe and provide better shipping and stuff to Europe, and that's been a big project. So first part of this year was spent trying to kind of keep that all going and keep kits in stock. And also been working on some new projects that haven't seen the light of day yet, but just things that I've had ideas in my head for a long time that I've been playing around with. And most recently, I've actually been spending quite a bit of time learning SolidWorks. So I don't know if you guys have played with SolidWorks before, but it's sort of like the Altium of mechanical, right? Like it's industry standard tool. Most companies that are doing mechanical, even if they're not using it, they probably have a seat of it, and it's everywhere. I decided that it would be a really good complement to Altium to have SolidWorks as well. And so I actually bought a seat of SolidWorks earlier this year and got a pretty good deal on it from one of our local guys that sells seats. And it took me a while because of all the travel to actually sit down with it. So I bought it earlier this year and I hadn't really logged very many hours in the tool. But this month I decided, you know what? I'm not going to let 2019 end without me becoming at least like basically competent in this tool. And it's hard. It's like not easy.
Had you done parametric modeling at all before in the past?
Not really.
Okay.
I've dabbled. Like I'd used SolidWorks before. It's sort of like I had a specific thing I was trying to do, and I just like crashed through the tool as ungracefully as is probably possible just to like get the part done. And like I'd have broken geometry to where I could never edit the part because I'd lost like history or I'd done something horrible. Yeah. But like I got the part done and I moved on to the next thing, and then I like never ever looked at those files again because it's embarrassing. It's kind of like how some of my Python code looks like, unfortunately. But I sort of dabbled, and I knew the tool, but if you had sat me down and say, hey, Jeff, I need you to make a donut, I would have said, oh, God, like I need to figure this out again.
How about a cylinder? I could do a cylinder.
I can do cylinders with confidence now. I'm definitely at that level.
Circle and drag. Is that it?
That's right.
Yeah, exactly. But man, there is so much. I mean, it's like Altium, where I feel like it took me at least a year to become like pretty okay at Altium. And I'd say I'd say I'm expert level, except that they keep changing the tool, and that kind of knocks me down because I just got beta 20 and I'd never really used Altium 19, and recently I also was like, hey, I should probably jump in and just learn the new user interface and sort of make sure that I know how to get this stuff done. And I had a project in mind, and so I sort of loaded up the tool and started working on the project, and I realized that I didn't know where any of the options were because they've moved so many of them between menus.
Yep, I just recently started using 19 as well, jumped from 17 to 19. Big change.
Yeah, that's like the worst possible jump. Yeah. Like I feel like you go from saying, hey, I am hot shit, I know what I'm doing, I know how to use this tool, like I could easily design a board in my sleep, and then you go to 19 and it's like everything I know is wrong. And I felt it was very humbling. And so I guess I got into this tools mode late this year where I said, you know what, I need to be on top of it for Altium, certainly, because I consider that one of my core tools that has sort of defined me as an electrical engineer for the past few years, or almost decade now. And I felt like my skills were getting a bit rusty, particularly when you added in the new versions. And then SolidWorks was like a logical extension, because I'd always been really frustrated that I couldn't make my own component models, or I couldn't modify the weird broken CAD that you get from vendors sometimes. And so even just changing colors and like doing all that really basic stuff. But then I said, you know, I should learn how to do enclosures, and I should learn how to do the things that support PCBs so that I can do sort of more product level, like EE and ME all together. And I have to say, I'm feeling pretty good. Like I still have a lot to go. I'm still a beginner, but I have been going through some tutorials, both the ones that are built in from the tool, and then also there's some tutorials online that I think are also like video tutorials that are pretty good.
I was going to say, are you just going to like buy a course or something? Because I'm sure there's no shortage of courses out there on those.
There's so
Udemy,
many. There are so many.
Yeah.
I haven't looked, but they do come highly recommended. I decided back when I was at Valve, I had looked at a couple classes that were given by CAD Junkie. One of my coworkers had recommended those, and so I had that kind of in the back of my mind, and it was like, you know what, I'm going to actually go through these tutorials that have been at the back of my mind now for years. So these are old tutorials. They're built around SolidWorks 2013, which is, several revisions back now. But I think they're good. And it's been fun to sort of follow through on that. I've been meaning to do it for years. And it feels good to finally finish those and say, hey, that was actually totally worth it. I should have spent the time years ago. But man, there are thousands of video courses, both free as well as, I think you mentioned, what is it, the Udemy stuff? Like, that's supposed to be really good too. I haven't gone down that path yet, but after I went through the built-in tutorials, there are many of those, like just the built-in tutorials that you get with the tool could keep you busy for quite a while. I was going to look at some of those other paid/free online courses as well. And I think actually there's this sort of balance where I like to do a couple tutorials so I don't feel like a total idiot, and then try to actually build something that I want, because that forces me to sort of figure out what I don't know. Because with the tutorials, you can sort of get this false sense of like, oh, I've got this, I know how this works. But it's not, that doesn't really apply to it's not a practical thing.
Yeah.
I just got a bunch of weird interference. Did you guys hear that?
Yeah, we got some little pulsing static thing.
Huh.
It's gone now.
Is that me?
No.
Oh.
Must be the interwebs.
Was it me? It could have been me. I was muting my microphone. But,
there you go. Yep.
Yeah. Weird.
Now, we looked into getting SolidWorks a year or two back, and it was just too expensive here. We pay the Australia tax here. And I did a video on this, exposing how expensive SolidWorks here. It was ridiculous. And
how much are we talking here?
Sorry?
How much are we talking here?
Oh,
let's get some relative numbers.
7,000-8,000 Australian dollars.
Okay.
Right?
Yeah, so pretty up there.
Yeah, it was a lot. And it would have been cheaper if I had bought the US version in the US, but you got to have a US address or something like that, I don't know, or a US company or whatever. And no, you pay the Australia tax. And it's bloody ridiculous. So
it's not cheap here either.
Right.
It's not cheap in the US
if people
either.
don't know, they've just got one price, and it's non-negotiable. And it's like
that is not true.
Well, it's non-negotiable. Last time I looked, anyway, it was.
My number one piece of advice for anybody that's looking into buying a kind of quote unquote expensive piece of software, Altium, SolidWorks are the two that I have the most experience with. The prices are never set in stone.
Altium's highly negotiable. Yes.
Yeah. And so my advice is, don't be a jerk to the sales guys, but understand that they have some latitude, and SolidWorks is the same, maybe not quite like some other tools, but I think that you have to be willing to walk away, especially if you're somebody like in my shoes where I bought a seat of SolidWorks because I wanted to learn the tool on my own time. I didn't have access to a corporate seat, and I felt like it would help me in my work. It would help me both in a future day job if I go back full time, but it would also help me in my contracting and sort of own product development work. And I thought it was a good tool to have, but it wasn't essential to me. And so I was in a position where I reached out, I talked to a rep, and I said, here's how much I want to pay. If this doesn't work this year, then let's talk again in 6 months or a year. And I think that's a pretty good strategy where you sort of leave it on the sales guy. Like if they're able to make your price, they'll call you back. They'll come back and they'll talk to you. Yep. And you have to be willing to realize that sometimes you're just not going to be able to get the tool for what you want to spend. But if you're willing to wait a year or two, you'd be surprised. You really would be surprised.
Year end when they have to make their sales targets. Unfortunately, I don't think for SolidWorks, I don't think that translates to Australia here. I believe that the reps here, the way they do their pricing is fixed pricing to the reps. So the reps here in Australia don't have the same leeway as they might in America or some other country. It's just some weird system that they've got in place with their dealers here. And you have to buy through the Australian dealer. And it's just, so unfortunately it just didn't work out. So we had to walk away and say, no, sorry, I'm not spending, $7,000 or whatever it was on SolidWorks, because there's a basic version and then there's, add-ons and things like that as well.
That's right.
And
and I've got the bare bones version too.
Right.
The professional versions were way outside of the range that I was comfortable spending, but I'm glad I did it because now I've got this tool and I can learn it at my own pace. When I was working full time, I always had access to it, but I never had the time. And so it's nice to have a little bit more flexibility now where I can say, you know what, I'm going to spend this week learning SolidWorks. Like, I'm going to be in the tool all day, every day. And I was never fortunate enough to have that kind of a situation previously. So it feels good to be able to just learn something, and spend a good amount of time, not just, because where I was is I would spend a few hours in the tool, I'd be pretty bad, and then a few months would go by, I would forget everything I'd learned, and I'd have to basically start over again, and I'm really trying to get over that hump this time.
You guys asked me how much I paid for my CAD tool.
Zippity-doo-dah. Well, no, it's in your monthly rent at your hackerspace, whatever it is. It's all built in, isn't it? No?
Oh, it's KiCad. I mean, it's free.
Sorry. I thought you meant CAD tool.
No, yeah, 3D CAD, I use Fusion. So,
right.
Yeah.
Yep.
Yeah, that's like a couple hundred
I know,
a month.
I have to say, pretty much everybody I talk to, guys that I've worked with, said I should use Fusion, and I've actually told a lot of other folks that they should use Fusion as well. Well, it's not quite
the
free
basic kind
anymore.
of one is it's free
if you're making less than $100,000.
If you're making less than $100,000,
that's right. That's right. So it's still free for individuals, but they've added some strings in the past year. And most folks that I've talked to have said, why on earth would you buy SolidWorks when you can get Fusion for free? And I think it was for me that all the tutorials I had that I'd been meaning to do were for SolidWorks. And I sort of just wanted to finish what I'd started. But also, in my maybe very limited view, SolidWorks seems like it has more adoption, particularly where mechanical intersects with PCBs. Like if I go to a company,
I think
it's
company,
more,
that's
it's
the key
more
thing.
likely that they are going to be using SolidWorks than Fusion.
Oh, for sure. I think that's the main thing.
That might change, but I think that's true today.
No, that is certainly true today. It's just like Altium, right? It's just like being a professional PCB designer and saying, I'm going to use KeyCAD. Sorry, Chris, but, like...
I couldn't get work if I was like, if someone asked me to come in and like work for a design house on contract, they'd be like, yeah, you use Altium, right? I'm like, no, I don't. Okay, well, we're gonna find someone who does.
Right.
Like that's fine. But that also helps me because I'm like, I don't want to go be just an extra hand. I want to build it from scratch and people that are. This is how I've worked my way around it, mind you.
Right.
Yeah.
You've been picking and choosing your clients to suit your narrative,
Yeah. If I was just going to be just a layout person, of course I'd go, learn Allegro or Altium or something like that and just work on, because I need to do it every day, like Jeff's talking about. So, I these are all, like we always say on here, it's, it's choosing a religion. It's not worth trying to change people, and it's, and each has their own benefits and downfalls, I think.
Well, I firmly believe that you have to, you don't just get to choose one. If you're going to be in the industry, you need to know more than one tool. And so I think it's sort of a foolish assumption to think that you can pick one and have that be your tool, because the truth is that all of these tools exist. People are using all of them. And honestly, even if you are just a beginner, so say that I learned SolidWorks and I say, you know what, I just want to spend some time in Fusion. Yeah. You'll probably be a better designer having done that, because you'll see how the other guys are doing it. And the same thing is true with the CAD tools for EE too. It's good to have a basic working knowledge of Cadence, Allegro, so that if you need to, you can get in the tool and be basically competent.
Or
you may
run
not
the
be
other
an expert.
direction. You could also do that.
Yeah. Well, all I'm saying, it's like
you're
operating
right.
systems. It's better to know all of them at some level, even if you're not an expert.
Well,
than
it's
to
good
just
to be
say,
able
hey,
to put
I'm
on your
Windows,
resume that, I have experience with that tool, but you don't necessarily have to be good at it. But generally, companies aren't going to use multiple tools. Like you're not going to have a company that's going to be using Fusion and SolidWorks or Altium and KeyCAD or something like that. But it depends. If you have divisions,
I disagree because I've seen it with my own eyes that a number of companies, particularly companies in the Seattle area, I talk to folks at, Hardware Happy Hour, and they're using all of the tools. Like they've got multiple groups who are working on different products. One product's using Altium, one product's using Allegro. I think that's like the new normal. Like that is now how... Really? Yeah, I really do. It's groups within companies are starting to behave more like startups almost. Like they have their own...
I was going to say it's got to be part of the startup thing where you hire the expert and then they bring in, you hire, right, I need a PCB person. You bring in the PCB person and they bring in and they use the package that they're familiar with. So if you start up another group within the same company, you hire another PCB expert or whatever, they'll bring in their tool and it's like, There's
it's like a gravitational pull kind of thing. So like whoever's the guru gets to decide.
Yep.
Yeah, that's interesting.
I have seen it too, but as a general rule, company, really like your higher-end professional company, like you won't find Boeing doing that, or you won't find, companies. Although
where they're buying
like,
200 seats too.
There are companies there are ones that I'm aware of.
I think with those big companies, what you're going to find is that there is one official tool,
and
then there's some guy who is using like Eagle to do his little board, his little adapter board, because he can't afford to go through like the regular channels.
Yeah,
that's true.
Because it takes 2 weeks to get a footprint defined or something like that. Like
right.
I think
that's how it used to go at Keithley. We would have like, we would have like 5 floating seats for the layout people, and then like you could get one, but you couldn't hold on to it because there's 4 people doing layout all day long, and then there's one floating around. So then we were using Eagle then, and then I switched over to KiCad. So yeah, that's true. Well, that's cool. All right, what else are you guys learning? So I actually just tweeted about this a couple days ago. I know it's early for like New Year's resolutions, but I was thinking about like what I want to learn in 2020. Do you guys have stuff you're looking to learn?
I probably have to get back into the software side of things, because come next year I won't have a full-time software employee, so I'll have to.
This is news.
I'll have to dabble.
Okay. How are you feeling about that? Is this why you were doing the toolchain install?
Yes, that's right.
Yeah.
Yes.
Okay.
David is moving on to greener pastures, and so I won't be getting another full-time employee. It's just it was basically an experiment that I'm not going to say it didn't work, but it's just like, I'm probably better off without a full-time person and just having,
so
if I need people to do stuff, it'll be contract based. Yeah. Yep.
Cool.
So to speak.
How you feeling about the software piece? I mean, are you excited? Are you nervous?
Well, if it's software my way, then I wouldn't be afraid, but and unfortunately, it's software the expert way. So,
I see.
Yeah,
object-oriented,
C++, C++. Like a lot of people have seen that install video. It's a 1-hour video just installing all the various tools required to get a simple power supply firmware running. So it's nuts.
Ouch.
Yeah.
Ouch.
Yeah, it's nuts. Because once again, that was the way that he chose to do it. It's like if it was me, like I just would have installed the vendor tools, written it in plain vanilla C. There's one tool, you just install it, just works, and everybody's happy. But because he's a professional software designer, no, that's not how, he started off doing that and he found a few limitations and he went, oh, bugger this, I'm just going to do it the normal way, in quote marks, that a real software person would, which is to install all these, various tools and things and, and do it all super duper. Well, to me, it's super duper complex. To any software person, it's just, that's just normal way to do it, But to someone who doesn't,
I guess it's sort of like it's like you have an operating system, or in this case you have a development environment, and so once you get it all set up, it's all cool because all the stuff that you want is all in the right place, it's all the way you like having it set up. But it's sort of like I feel like Python is still kind of like this, where if you need to use libraries, sometimes, I remember, what was it? SciPy was like over a gigabyte download.
Oh yeah.
All the packages that are included in that. And so, if you wanted to do some automation code that's using, Visa, then you would need to install this gigabyte download. And you only really needed like a package or two, but that was the easiest way to get it.
Yeah.
I remember doing that.
Painful.
Yeah.
Yep. No, because I come from the background where it's just you use the vendor tool or whatever, or you use your C compiler of choice. Sometimes I've used like a third-party C compiler or whatever, but just write it in plain vanilla C. Nothing fancy. I didn't need to do anything.
I mean, for me, it's chase as many examples as there are available, and then whatever find the least common denominator, and that's what I'm going with. Yeah, Vendor Tools has 100 examples. Yeah, I guess I'm using the Vendor Tools. Someone else has 100 examples. I guess I'm using those other tools,
Yeah.
Yeah.
What about you, Jeff? So obviously your mechanical stuff is continuing on, but I think
that's definitely going to continue into next year. I think getting up to speed with the latest versions of Altium, as I mentioned, I haven't finished that, and I think my dream here, or my goal, is to be able to do electrical and mechanical co-design, sort of all myself, all with tools that I've got, and then using 3D printing to sort of be doing iterative development.
Just making widgets.
Have that whole thing, you basically get that whole flow working. I've got a Prusa that I've had for a few months now that is great, but I have yet to really incorporate it into sort of the serious engineering work. It's mainly been printing little toys and stuff like that, the things
stuff
on Thingiverse
Thingiverse,
that you... Yeah, exactly. So I've been at that level. I haven't done a bunch of custom part design. I've done a little bit, but it's been
doing like a boring project box is like something you haven't modeled yourself and done. Yeah.
I haven't done project boxes, and I've learned what little I've done. I've learned that it's actually difficult to do structurally sound parts using 3D printing. Like the settings you use are not. It's not super well documented. Like it's easy to make something pretty that you can look at, but if you want to make a part that can actually support weight that you could use as like a bracket, say you're building shelves or something like that, and you want to build brackets.
Why are you 3D printing this, Jeff?
Well, because I can.
So what you're telling me is that the dream of 3D printing from 10 years ago didn't work.
Oh, no.
And didn't come to fruition.
That's not true. That's not true.
But everyone would have one. Everyone would have one in their home, and they'd be printing doorknobs, and they'd be printing, everything they needed for their home. You would never have to.
I can see now that I've opened a can of worms. You guys need to, when I'm on the show, give me like a little list of words not to say. Like here, don't mention the chip printing. Chip printing is off the table.
Printing. Yeah. Chris, where's that 10 years later, huh?
So I want to say, I think everyone should have a 3D printer at this point, and I think it's not because you're going to print doorknobs, although... I'm not going to print doorknobs. I don't think anyone's going to print doorknobs. But I do think that 3D printers are finally at a place, and maybe they've been here for a while, but I think they are at a place where the average person can buy a 3D printer, have it working in a fairly straightforward way, and be printing parts that are useful in some way. And so,
and you can do it for less than $1,000, probably less than $500.
Yes, absolutely.
Yeah, I agree with that. I agree with that.
And I think we're at this place now where... Like, I got one because I finally realized that the thing that I'd been holding out for so long, which was soluble support material, I saw what people were doing without it, and I saw that it seems like it's just not going to get there to where the kind of hobbyist level printers are incorporating this at a level where it's been present in industry for so long. But I said, you know what? If everyone has these printers and they're printing parts that look like the parts do, that clearly this is not like a deal breaker, that you can print
do regular
useful parts
supports
without it.
They don't need to. Exactly. They don't need to melt away.
Yeah, and so I jumped in and said, "Hey, I think I'm going to try this." And I have to say that it is pretty great. So you're not printing doorknobs, but you are printing like custom weird brackets for like I did a Wi-Fi. Like a repeater that goes from my house to my garage because they're separated. It was easier than running a cable. And the repeater didn't come with any kind of mounting hardware. And these are up in the attic, so they're exposed to really high temperatures. And the design I made for it was kind of cantilevered, and so it had to be mechanically sound. These are the brackets that I'm talking about. And I could not have bought a thing to do what I wanted, and I probably could have cobbled something together out of U-channel or angle aluminum or something like that. But I said, you know what? I have a 3D printer. I should be able to do this. And actually,
how
I have
many
to say,
hours later did it take you to do the 3D model?
It did not take that long. It was fairly simple geometry, and the thing about it was that it was a great crash course in how to print things that are strong, which I think is not straightforward. It's not something that everybody just knows how to do. The tools don't have good defaults for strong, having multiple outside layers, changing the fill patterns and the fill densities to get really strong parts. I feel like, at least for me, I had to learn that. But also, it helped me learn mechanical design because honestly, the first couple parts I designed were horrible. Like they were not mechanically sound parts. Right. And so by building parts that sucked, I learned how to build better parts. And if I did it again, I'd do it totally differently and I would have a better part. But it was actually a very, very good learning experience. So for that alone, I would recommend that people get 3D printers and do this, because I feel like that learning is actually very valuable, and that value transcends the fact that, yeah, a lot of the stuff we're printing is maybe not, not everything that comes off the printer is going to change my life or do something that it is like dollars per whatever at the cusp of like, yeah, this was a good investment. But I actually think that the learning that's coming off of it is by itself totally justifying purchase of the printer. So I'm really happy that I did.
All right, we got one. We got one. That's good. Yeah.
So yeah, learn mechanical, learn double E, get back on top of some of these tools that I'm starting to feel a little bit out of touch with, because I'm a couple versions behind, and really trying to get that mechanical, electrical co-design down so that I can do not just PCB level, because I've always been a very board level person, very 2D, like very, very comfortable at 2D.
Yeah.
But as soon as you go 3D, I've never been as strong at that, and I want to try to solve that in 2020.
Yeah, starting to do like flex and rigid flex and stuff like that.
Exactly.
So it sounds like you've encountered the very common thing of, once you leave professional industry in quote marks, i.e., working for a company with big projects and big resources, you start to lose your skills, so to speak, because you're not working on those big projects on a daily basis.
Yeah, I agree. And I am very aware of that. And I'd actually say that even at the big companies, the problem that I've encountered is that, and this is my own personal experience, as time went by, I was increasingly working on sort of management level projects where there were a lot of contract negotiation, a lot of project proposals, and working with vendors. And I wasn't spending as much time low level in the tools. And so even when I was working full time, I wasn't at the level. So 2 or 3 years ago, I was in Altium like 8+ hours a day, every single day. And I was having like carpal tunnel problems because I was just so,
I want to get back there. I really want.
That's
I
right.
miss the pain,
It wasn't all great.
Makes me feel
but
alive.
you are so ridiculously efficient when you're doing that.
Yeah. So, I was at the point where I could have told you every bug that Altium 16 had. Like, I knew all of the problems that all of the different versions had. And I don't feel like I'm at that place now. So you're absolutely
I'm sure
right.
they've gotten rid of all the bugs too. So
it is absolutely the case of where, now that I'm not working full time for a kind of medium-sized company, that it is, I do feel like I'm starting to lose touch. Like, I had access to a lot of incredible equipment, especially RF test equipment. And Chris and I, we were just talking about this recently. There's so much there that if you have like a 40 gigahertz VNA sitting on your desk, you throw everything at it. You're like, I want to see what this looks like. I want to see what this looks like. And it has TDR and all these things. And I actually felt like, for me, it was great to be close to the tools again, because I started my career in RF and I'd worked in RF for so long. I hadn't done a huge amount of RF when I was at Valve, but was starting to. And I think that felt really good to get back close to the equipment. Well, now I don't have any of that equipment again.
Jeff, you can just buy it. I mean, a 40 gigahertz VNA is only
oh man,
I don't know, $90,000.
No, that's not true, but certainly tens of thousands of dollars.
Oh, okay.
Yeah, I mean,
I saw that one that was a 60. I mean, that one that's on my presentation was like a 68 gigahertz, and that was $500,000.
That's a really nice VNA. I mean, you can get a 40 gig VNA for, I don't know, probably 40K maybe, something like that. Yeah, I'm not sure. I'd have to.
All right,
I'd
well,
have to check.
That's only half of what I said, so I wasn't that far off.
It's when you're talking about like the 4-port high frequency stuff, then like everything they're doing is times 4, and it gets really expensive.
Yeah,
but you can get some 2-port devices for less.
Well, I should say that Jeff has been my spiritual and actual advisor for all things RF. My presentations that I gave would not be anything without Jeff. Basically, he helped walk me through a lot of them. So thank you for that, Jeff. I appreciate it.
Yeah, thanks, Chris.
Yeah,
it's been fun. It's fun to go back to kind of trying to think, okay, if I had not done this before, what would I tell me?
It's tough, it's hard. Thinking about like what was confusing when you're getting started. Like It's even writing it down, like writing down what I'm struggling with, it's still not going to be that same feeling, like that feeling of just like, man, I just don't know where to turn next. I don't know what to Google for. Like, that is just a really tough feeling. And I really try and empathize with that whenever people are learning new things. But you just, I think that's why you got to try and learn new things as well, to just kind of keep that fear in your heart,
Yep.
So, yeah.
I was going to say, I always get a kick out of, I read Reddit, and there's the "What is this thing?" subreddit.
Yeah.
People post photos of things that they're trying to figure out what they are, and it's kind of a fun game because, even if the answer's there, you can sort of see the guesses, and it's always funny to see the ones that are like way, way wrong. And I always think it's interesting because sometimes the way in which someone asks the question is very telling, because it shows you that they're not thinking about, like, the reason they don't know the answer to what is this thing is because they're just not thinking about it in the right way. Like, they post a single blurry photo that doesn't show any details, and people are asking, like, hey, show a high-res photo of this manufacturer's logo or something. And I think it's telling because you sort of think, oh, well, so we'll talk about RF, like, a connector is a connector. Well, no, connectors are actually, even if they look very similar, they can be like very, very different, even to the point where trying to plug one into the other will damage both connectors. Mm-hmm. That's hard.
I know what he's talking about now, Dave.
To figure out.
Congratulations.
I'm on the verge of breaking a lot of expensive things. So, yeah, I have that fear. So Jeff's talking about SMA and 3.5 millimeter connectors.
That's right.
Yes.
Yeah. They look very similar, very similar. They will plug into each other, but they're not guaranteed to work without causing damage.
Yep.
Or degrading the performance.
That's right.
Because like, if you've got a scope if you've got a 10 gig scope that has BNCs on it, they are super special BNCs. They are not regular BNCs. You can come a guts if you go and try and plug your $10 probe into that. It can degrade its performance.
Yeah,
so,
right. Have you guys ever seen those high voltage BNC connectors that look like BNC connectors, but they're not? They have like a bigger insulator around the center pin. Yeah. That's another where they will mate, but you'll probably break something.
Exactly.
If you push hard enough, you can get them to plug in.
You can put it in, And that's why you buy your $1,000 test leads to go with you.
Yeah, right.
$20,000.
I think about the triacs too. I've tried,
triaxials,
big on triacs,
with
and
yep.
Man, you did nothing more confusing. You're like trying to plug it in, you pull it out. You're like, what the hell is this extra? What's this ring doing
it's
here?
A triaxial.
Yeah.
Good stuff.
How are your RF explorations going, Chris?
Good. I've been waiting on shipping for connectors, as you would imagine. So I have my new 8753D, which I've mentioned on the show with Dave, but I didn't have the front end connectors on there. And obviously Jeff was walking me through a lot of that. I also talked to Tom Anderson, who's a Keysight guy, and I actually ended up finding some on eBay. So I ended up getting APC 7 to N-type. And then I'm going to go from N-type down because those were much more available.
Yeah.
So
and N-type are basically indestructible. So they should last a long time.
That's what I was thinking too. Yeah. So I probably will never pull the APC7 to N-type connector off the thing unless I'm transporting it. I don't want to knock it around.
Yeah.
So
that's a good idea.
Yeah.
I'm thinking about getting into EMC, far-field EMC. Testing now. I've got myself a little. I bought a little, one hung low brand EMC antenna thing, and unfortunately, it only goes from 200 meg up. So it's not, it's not the greatest thing. I did want the wideband one, the 30 meg to 1 gig range to do the whole span of the CISPA standards, and so I had to sort of compromise and.
Can you define the far field versus near field?
Far field versus near field. For those who don't know, we'll have to link in the video on this. I've done, which I think is quite a good explanatory diagram of how this works, is that electromagnetic signals, EMC, stands for electromagnetic signals. Well, when you're up close to the component, when it's radiating, when you're up close, that's primarily especially for currents, like for large currents, that's a magnetic field. So that's when you use what's called a H-field probe. That's a magnetic field probe. You know, those circular ones. I've done a video on how to design your own, build one for $7 or whatever. And
that's also the one you bought and you had it right. You hold it over the chip and you can kind of
hold it over
monitor.
the chip and you can get that. What you're measuring with that is the H field, and you can also do the E field as well, which is the electric field, but it doesn't become EMC radiation until a certain distance out from the board. That's when the magnetic fields and the electrical fields meet, and then it becomes EMC, which is electromagnetic field. So you have to actually test, and so that then becomes what's called the far field. At that particular distance, it's based on a wavelength of the frequency you're trying to do. So, at 30 megahertz, which might be a minimum specification for the CISPA, various CISPA standards that they use, 30 meg up, I think that distance is a meter or something. So, or, half a meter or something like that. So your antenna has to be half a meter away or more, and then you're measuring the EMC radiation from that board, the combined electro and magnetic, and you're doing that in the far field. And
the C in EMC is usually compliance, right? That's the
EMC compliance. So it's electromagnetic compliance, and and that's how they measure it in the chamber. They generally will not measure near field. The near field stuff, which you do with your little H field probe and you wave it over your board close to the components, that's just for troubleshooting and stuff like that.
Testing.
And you can get some basic EMC type readings from that, but it's really only when you go to the far field measurement that you actually get the real measurement, whether or not you're going to pass or fail an EMC standard, for example.
I think just turn your whole office into like a anechoic chamber.
Into a big chamber, yeah.
But also because that foam, it's really good for sound, so your videos sound better, your amp hour sounds better, it's just great. I'm sure it'd be cheap for
I think I'm just going to go to a park. Like I'm just going to go to what's called an OATS, which is an open area outdoor test site. I'm just going to go to find a big park on Google Maps and just go there with my little portable generator powering my
just cost you a tank of gas, right?
Yeah. And do it that way. I think that'll be easier than trying to get decent far field EMC measurements in a office building like this. I think it's going to come and guts us. So I want to do that. I want to do a video on that. So
that's cool.
Yep, but it's not easy. Once again, getting the right the right tools for that. In theory, it shouldn't be hard, right? These are just pieces of bent metal, right? Like if there's a niche market here.
It's just a piece of
the antennas are basically a piece of bent metal, right?
If there's any antenna designers listening, they just
exactly
they just
shit their pants,
the one I've got here now, like I got it from AliExpress, and it's as I said, it's like 200 meg to 1 gig, and it's a large PCB, so it's just one big PCB. So it doesn't cost much to make, right? It's just basically a single PCB, a double-sided PCB, right? And
I feel like this is like saying software. It's just ones and zeros.
It's just ones and zeros. It's a similar sort of
ones.
thing. But you see, if somebody could if a real antenna designer with the real tools to then characterize the performance of it, they could sell a $100 EMC antenna and they'd sell, thousands and thousands of them. Right, everyone would be buying it.
You're saying get it qualified and actually
get it qualified and get the
process.
proper plots and things like that, and make sure it's characterized, and you provide a data sheet for it and things like that. And if you can do that, then but otherwise these antennas cost
thousands of dollars. You got a year until next Keyzermas to get this figured out, man.
They cost thousands of dollars. There's a great niche market there for that. Especially like the broadband. As I said, I can already buy the 200 meg and up, but if somebody can do a 30 meg to 1 gig one, then a combined wideband antenna one, there's just nothing like that on the market. I cannot buy one. And I thought, some antenna designer would go, I can do that and I can design that in 10 minutes. And here we go, I'll sell that on my web store, No, nobody's doing it. So, And then I went to Roden Schwartz. I contacted Roden Schwartz because they're one of the leaders in, EMC testing stuff, real expensive EMC testing gear and stuff like that is one of their niches. And they went, no, we basically don't. And they had one of these wideband antennas. I looked on their website and they go, oh, maybe, I was begging, look, can I get one of these, fancy-pantsy wideband EMC antennas? And they go, well, no, we don't actually carry those here in Australia. We just don't have any test houses, so we don't bother, carrying this, fancy-pantsy antenna. Like, can't even get it in the country. Ridiculous.
Well, yeah, okay. Well,
so please,
Jeff,
somebody.
So maybe we should add, antenna simulation software to our to-do list.
Expensive tools. We'll start negotiating with the vendors on that.
God, yeah.
I think that's another order of magnitude, though.
Yeah, I think it is too. Yeah.
Yeah.
But seriously, Jeff, that's a great niche product for you. I reckon.
So I thought Henry Ott had a list of kind of relatively inexpensive tools. He has this EMC crash cart that's in his electromagnetic compatibility engineering book, and I think he mentions antennas. If not there, then I've seen in a couple other publications. As I mentioned, I went to the EMC symposium, the IEEE EMC symposium this year, and there were a couple panel sessions on starting your own EMC business, and they were talking about low priced equipment, like the cheap spectrum analyzers that you can get today, stuff like that.
Rigol's and things like that.
Yeah, exactly. I didn't notice any antennas, but you're right. That does seem like an opportunity.
There's something missing there. Yeah, you can buy the cheap, for $1,500 now. You can buy a complete spectrum analyzer that'll do the whole wideband range with the EMC compliant filters in it and things like that meet that are used for the standards.
Yeah, it'll show you the drop offs and stuff like that.
It'll apply the correct filter characteristic and the correct resolution bandwidth and everything that's sort of like standards compliant, so to speak.
Yeah, so, it's the quasi peak filter. That's the key.
The
that's
quasi
the special
peak filter.
sauce.
Yep, that's the special sauce. That's
and make sure that they actually do use the right filter, because if they don't, you don't get good data. I've had that happen before.
Yep,
it's
totally.
Bad news. I think that EMC testing is something I've done quite a bit of EMC over the years, and that's an area that I've often thought, I should do more work in that area, because people think it's like a black magic sort of a thing, kind of like RF.
Yeah,
and
for sure.
There is an element of uncertainty to it. I think that's the problem, is that sometimes it's not straightforward to fix things if you don't know whether it's the cable or the unit that you're testing, or some software or something else like that. And I think that's why it has that reputation. Like, you have the image of the guy putting a ferrite bead over a cable, and magically the product passes.
It passes.
And,
that's it.
And I think there is some truth. There's definitely some truth to that, but I also think there's a design aspect to it. Like, you can avoid a lot of problems if you do good design.
Yep.
And that's an area that I've done quite a bit of work. Like, ESD is also, fits within that EMC umbrella. And ESD, sometimes your first approach is absolutely not the right one. Like, it's easy to make things worse by trying to fix ESD problems with insulating tape and stuff like that.
Right.
And that's the kind of thing that, unless you're actually sitting there with an ESD gun and spend some time with it, you don't learn. So I've thought about doing more of that kind of work, just because I've got experience with it. And there's an EMC society in Seattle, and they do workshops periodically, and I went to one this year, and it was a lot of fun because it was at one of the test labs, and they were talking about reverberation chambers, which I had never even heard of before, but apparently Boeing uses them to measure EMC in aircraft and other big stuff that you can't fit in a chamber.
Not with that attitude, you can't.
Well, yeah. The solution for small devices is you have a chamber that has anechoic shielding, non-reflective shielding on the walls, and that's how you sort of cheat. So you don't need to have a huge environment for testing each, and like a cell phone sized product. But an airplane, that's a whole nother story. That's a lot of work to put an airplane in a chamber.
Yeah. I've been inside Australia's biggest one. I've done a video on that where you can actually drive in big, they can test army trucks and stuff like that, and the door is just, it's gigantic, but it's not big enough for a plane. Obviously, that's, really something. really something special. So, yeah.
Jeff, what else did you learn in that at that symposium you went to?
Which one? The one in New Orleans?
That was the EMC one, right? I mean, like, what was the genesis of you going? Was that just for networking, or you were just generally interested?
I was interested. It had been a while since I'd been to an IEEE event. I've been an IEEE member for a really long time, since I was an undergrad, I think. And I subscribe to a couple of the publications. You know, I'm a member of some of their, what do they call them? Their groups. So I went to the IEEE EMC symposium because I wanted to go to an IEEE conference. I'd gone to the microwave MTT conference, the Microwave Theory and Techniques International Microwave Symposium, when I was starting my career. That was sort of the conference I went to every year, but it had been a long time. And I'm sort of fascinated by EMC because there's this sort of like hands-on aspect to EMC that I think is more prevalent than other areas of electrical engineering. Like you've got antennas, you've got, it's like a very sort of, I think, well, I mean, there's definitely a research and a theoretical side to it, but there's also like a large practical side to EMC.
Right.
And I thought that was interesting because I think if you understand EMC, you'll definitely be a better PCB and a better product designer, a better firmware engineer, like better all these things. If you understand how to fold, because a lot of
you can fix EMC problems in firmware.
Yeah, absolutely.
Oh, yeah.
Absolutely.
Oh, yeah.
Let's hear a little more about this.
Eyes are lighting up now.
Yeah. Well, I'm just curious. What you guys obviously have very specific examples. I just never.
Yeah, I mean, it's like error correction and error recovery. Like if you have a firmware that is easily crashed by an EMC event, how it recovers can determine whether.
So it's on the receiving end, though. It's not on the sending. I thought you meant like it would be like.
Well, no, sure. It's on the. I mean, like spread spectrum clocks are.
Yes.
That's a firmware controlled thing. Like how you communicate, the speed at which you communicate with devices can influence things. Like you can also update rates.
You can also configure your IOs in your chip. A lot of higher speed IO micros and things like that, and FPGAs will have controllable slew rate outputs. So you can go, okay, I want a lower slew rate output so the edges aren't as fast, so you're not generating the high frequency content right up in the high end.
Burn a little more power doing it or something, but then.
Well, it's a bit slower, and you could burn a bit more
power doing it through the transitions. I mean,
yes. So there's trade-offs there, but no, you can certainly magically pass your. You might fail, and then you can magically pass your EMC standard by setting all your slew rate outputs slow.
Right.
And bingo, you pass.
Right. I think that So a lot of people, I think. Maybe there's an image of designers that think EMC is just this like bunch of red tape that you need to get through to ship a product, right? So you've got the design team and they're like, oh man, now I have to deal with all this EMC stuff. And, why are we even doing this? Why is this even important? I firmly believe that the majority of requirements for EMC, if you pass, will result in a better product for the customer. Like a lot of it is not just making a product that's compliant with the laws about, emissions and things like that, but it's also about having products that don't crash when you walk across the carpet and spark to them, with static coming off your finger, things that can deal with interference. And Europe is much better about this than the US, but having products that resist interference from other products, I think those things, generally speaking, make products better. Like it's good that those requirements exist because I think that they highlight the vulnerabilities of products in this sort of modern digital world where you have a lot of stuff in the same RF or same electromagnetic environment where you've got your vacuum cleaner that's causing your computer to crash and stuff like that. Like the reason that stuff doesn't happen more is because there's testing that is required. Like products have to meet a certain bar. And I actually think personally that bar that is set by EMC a lot of times is the minimum bar. Like that's not what we should strive to as designers. We should try to do better. And I think ESD is actually a great example. The ESD requirements for like a consumer product is 4 kV contact discharge and 8 kV air discharge. So that's the magnitude of the voltage of the spark that is hitting the device, be it from a metal, like a fork that you're holding onto that you're touching the product, or is jumping the gap between your finger and the front panel of your VCR, for example, or your DVD player. That's the minimum standard, but that's that's not adequate. Like it's sort of like the minimum pieces of flair from Office Space. Like it's not okay to have the minimum pieces of flair. Because in reality, 15 kV is totally typical. Like it is absolutely normal to hit stuff with 15 kV.
Oh yeah, you walk
and
across
as product
carpet,
designers, that's right. Like if you on a dry day, which this time of year in Seattle, in a lot of the U.S.,
Chicago,
things start to get really dry,
and
and it is not unusual to have a much, much higher level of ESD in your home or in your office or whatever. And so I think as product designers, as engineers, we have a responsibility to make products that work, and that customers, people paying money for those products, are going to be happy and that are going to last a long time. And I think that by meeting the minimum, you're not necessarily guaranteeing that. And of course, it depends a lot on the situation and the product. If you're making some throwaway conference giveaway thing, light up keychain, who cares? Like maybe it's going to work for a week. I'm not even sure that we should be making those devices in general. But say, that product compared to a cell phone is a very, very different thing. A thing that you handle every day and is going to experience hot and cold and dry and wet and big sparks and little ones and different RF environments. That has to be held to a higher standard. And I would argue that the companies making those devices, I would say by and large, they have internal requirements which go beyond the requirements of EMC. So I guess, so long story short, I think this stuff is interesting. And so I decided to go to this conference just to see what was going on. And it was actually really cool. And not to mention, it was in New Orleans, which is an awesome city. So it was in a great location. If it had been in the middle of nowhere, I may not have gone, but I was I was eager to go because it was in a city that I'd never been to before.
Sorry, honey, I have to go to this boring conference. Sorry.
Yeah, that's right. Yeah. I'm not going to slander any other cities in the country and say that, if it had been somewhere else. But the reality was that I was really excited to see New Orleans, and I was also excited to go to this conference, which I thought was really cool. It was a really neat group of people, and it's a small enough event that a lot of people knew each other. And I went to an amateur radio meetup during the conference, and that was really fun. It was great. I was glad that I went.
The good thing about the EMC design compliance, if you design your product with EMC emissions in mind, almost by definition, you get free robustability in terms of EMC
immunity.
Reception, immunity.
Yeah.
So if you design it not to emit, then by nature of actually designing it not to emit, you're also going to be less susceptible to external stuff upsetting the apple cart. So
I think there's truth to that. Yeah, I think that is
because
definitely
generally
the case.
all your loops are tighter. For example, it's one of the big things in PCB layout to not emit too much is to keep your loops nice and tight, especially on high current loops and things like that. And if you keep your loops tight, that means you've got less reception area as well when when other EMC stuff is bombarding your product. So it just it's almost you practically get that for free. It's a bonus.
Yeah, it's true. It's like having the shield connected on your cable, right? Like if you connect the shield, it helps you reduce emissions and also improves your immunity.
Exactly.
So one last thing on the learning. I know that we're pretty much only covering that since we're almost done, but I have a goal to learn Qi charging this year too. I mean, I think that'll be pretty easy, but I've not done it yet. So
Qi is still the de facto.
As far
standard?
as I know, yeah. I mean, you can.
I think it is, isn't it?
I mean, you could do like just a air coupled transformer, air coupled transformer, but.
Oh, you're talking about actually rolling your own.
You could do that. I'm saying, I'm not going to.
No. Why?
Right.
Qi has been engineered to be, efficient, low power. You can buy the coils for practically nothing off the shelf, and you can buy the controller chips off the shelf. Why would you roll your own?
Is Qi the one that uses BLE as like a back channel from the charger to the device?
No, I think it just sends bits
maybe
through.
There's some extended layer of it that does, but generally no, it doesn't.
Okay.
Not that I'm aware of. I could be wrong. As I said, there could be some extended version, but the basic one, was just coupled via the coils.
Yeah, I think at this point too, it's pretty much buy a chip off the shelf and buy the coils off the shelf.
It's a buy a chip off the shelf. You can buy them from straight off DigiKey or Mouse, so you can get the chip and the coil and everything, and just whack it straight in the bottom case of your product.
Yeah.
And
I just,
Bob's
I
your
haven't done
uncle.
it. So
Charge
it's
you
like
back.
that fear of the unknown kind of thing. And yeah. I've noticed that like as I've been writing firmware and like delving into spots that I don't know what I'm working on, like I can always tell that I'm really procrastinating if I open up Facebook. Like I don't use Facebook anymore. But if I'm like, why am I on Facebook right now? Oh, I don't want to be doing what I'm working on. It's like it's like my fear response, Okay. And so yeah, it's
just a place to kill time.
it's just a way to escape for a second, and but it's good now if you recognize that you can kind of go back. And so Dave, what I'm saying is, as you're picking up more software firmware this year, if you're on Facebook, you're just stressed.
I'll just go and browse Twitter or watch some videos
forum,
on YouTube
I'm sure,
or something. Forum, YouTube.
Yeah.
How many hours a day? I could be much more productive if I simply disabled YouTube and the forum. I'd be incredibly productive.
YouTube's a tough one. That's my
Yep.
I've kind of trained my brain to like like if I'm eating anytime these days, I'm usually watching YouTube, which is like a really bad association.
I need the dopamine hit of YouTube,
Right.
I get all these email inboxes. Oh, somebody's released a new video. It's like, and generally it's got nothing to do with engineering. I'm not, well, in our field anyway.
Mm-hmm.
Electronics. I do follow other electronics channels, but I generally don't watch electronics YouTube videos unless it's something very specific that I'm after. I'll be watching, other science-related stuff or other things. So yeah,
it's good. You're branching out. That's good.
No, it's because I know electronics. It's not like I know everything. I know hardly anything after all these decades.
Right,
it's still,
But you want to mix things up.
Something new every day. But I don't actively follow any other YouTubers. Religiously watch every one of their videos. So yeah. Whereas I'll do that for other science channels or astronomy channels or space channels or things like that. So,
Jeff, what else you got for us, man? You're our dancing monkey guest.
Perform, go.
Yes.
Oh gosh, I didn't prepare. I don't have like a little song.
No,
Christmas
we didn't
tune.
prepare the amp hour. No.
What else would people not know about you?
Oh, I don't know. I've been on this show enough times. I think people know everything.
Have we brought up your tiki obsession or your Sunbeam? I guess we brought those things up, but
Sunbeam.
Probably have. Sunbeam is a British sports car that was
thought
made.
it might have.
money
That's
pit,
the
Dave.
first
That's what it
thing
was.
that came to mind. Yeah.
It's a money pit.
Because you're into cars. Yeah. Right.
Yeah. So I've got this project car that I've been trying to get on the road for like 7 years now. And
Right.
been
because he keeps
through
3D printing
many
the
trials and
tailpipe.
tribulations.
Right.
No.
I was actually thinking that when you were talking about 3D printing, I was like, oh god, I hope Jeff's not 3D printing parts for the car.
I have actually. So I do. I watched a video. So talking about YouTube and like YouTube holes, like things that suck you in, and an hour later, aluminum casting is one of those areas. And there was a video not that long ago where someone had made an intake for like a kind of obscure Audi sports car. And had made like a mold and had 3D printed part of a mold and had used like lost sand casting or something like that. And of course I went and I chased down the books that he mentions in the videos. And there's these books from like the 70s that are talking about casting techniques. And I actually think that doing printed like intake manifolds, similar to what this guy was doing, I think that is actually a very practical application of 3D printing. Now, it is a huge amount of work to go from a printed part to a part made out of metal that you can put in your car. Yeah. But I think of anything like 3D printing enables rapid prototyping of things like that. And I'm actually not sure. There may be services that would take a model and then make a cast part out of it. I mean, certainly you could machine it, but casting, I think, is uniquely suited to making intake manifolds because they're tend to be really curvy and they have really complex shapes. I'm not sure that it would be practical to machine, and you wouldn't want to make it like 2-part where it comes apart. I think you'd want to make a single piece. Yep. Anyway, I've thought about applying 3D printing to that. It's hard because the parts tend to be big, so you need to make them out of multiple pieces and then
you might have a seam in your metal part.
Yeah,
too,
exactly. But the part that this guy printed on YouTube was really impressive. Like it was amazingly well done. So I'll see if I can find a link to the video because it was a neat it was a really neat video to watch, and the guy had made other videos as well. And the books are cool too, and I think for the most part you can get them online. Like they're old enough that you can find PDFs of them places, and you can buy used copies for cheap. So that was a thing that I'd been exploring. But yeah, I'm still working on cars or trying to. I've got exhaust project on the Sunbeam right now that I'm trying to get sorted out so I can get the car back on the road. I was dealing with the fact that for the past, I'm actually not sure how long, but in the U.S., they being the people who sell us gas, started adding alcohol to gas.
We've got that here. It's called E10. We have 10% ethanol.
Okay. Yeah,
that's common here, and it's actually cheaper. It's cheaper than regular, fully unleaded
right.
petrol. Yeah,
that's right. So that's common in the U.S. too, and it's been the case for quite a few years now. And there's actually a couple problems to that, and one of them is that ethanol lowers the boiling point of gasoline.
Yeah.
And you might think to yourself, well, why do I care about the boiling point of gasoline? Well, if you have a carburetor, carburetors are how old cars particularly measured the amount of fuel that goes into the engine, and it's really critical to get just the right mixture of fuel and air to create the most energy and to have the combustion be happening in a favorable way for a car. Carburetors sit on top of the engine, and well, on top of the engine it's really hot. And so one of the problems that I've run into with this car is that the carburetor setup was actually boiling over. The fuel in the carburetor was boiling and then actually traveling down into the engine. And so I've been designing heat shields and things to try to reduce the temperature of the
Nice.
carburetor.
Yep.
So yeah, I have this sort of parallel set of hobbies that are out in the garage that are dealing with these really fundamental problems of trying to manage heat and stuff like that. But it's fun. I've had that hobby for a long time, and
I mean, in 7 years, Jeff, you should have electrified this car at this point. I mean, like, honestly, there's no heat problems then. It's just a shitload of batteries.
That is a very controversial thing. So it is very true.
Yeah, but if you're on like forums for like a bunch of gearheads, then of course they're going to say that. But if you just want like a car that goes, I don't know. There's still a bunch of mechanical stuff there.
I think there's arguments both ways, and there are companies that specialize in the electrification of classic cars.
Oh man,
there are
long time
companies
callback. Bob Simpson was on the Amp Hour on episode 112.
Oh god,
and he did that with his BMW. So people can listen to that one.
Yeah, so I've known
How did
people
you remember
who've
that,
done
Chris?
this. Yeah, how do you know that, Chris?
I just remembered his last name, and
and you're googling in the background.
yeah, I'm just googling.
Yeah, right.
Yeah, I'm just like, and then 113, Dave, you and I talked about blah 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 blah. Yeah, right,
exactly.
Man. I can't remember what I had for breakfast.
Well, so I wanted to say that it is a very controversial thing, and I totally get why people do it. I don't know that I would ever do it, and for me, it's because the experience of having an old car is not just having the thing you look at, it's like what it smells like and
you also want to be broken down on the side of the road.
That's right. How often are you broken down on the side of the road where, a hose has come off and you're stranded hundreds of miles from towing range?
Right. Yeah. This sounds great. This is quite a hobby.
I think that it is a core part of the kind of vintage automotive experience to have the internal combustion engine. But I will say that more so than at any time in my life, I feel like now the writing is on the wall that is not going to be sustainable forever. I think it only recently has it really become obvious.
So you just got this, Jeff?
Well, I guess I'm saying,
we might run out of petroleum. Have you guys heard about this?
No. I'm not saying that. I'm not saying that. So I think that's been clear for a very long time.
Yes, I know.
But I think that what's changed. No, I know. But I think that what's changing is that the idea. So say that we're all driving electric cars or some other means of transportation for our day-to-day lives. Mm-hmm. I think that we're getting to a point where even if you wanted to have an internal combustion engine in a vintage car, it's going to start becoming very difficult to actually maintain that and have that.
See.
Because those parts are not getting any younger.
Yeah, or you'll have to do like the thing that like Jay Leno does and like, have a full shop where you're machining custom parts. So like you're talking
about. That's right.
Yeah,
and it's not practical for most people to do that for every old car that they're trying to keep on the road. And I think that the writing is on the wall. I mean, at some point, if we do move away from fossil fuels, the infrastructure for fossil fuels is going to start going away, right? Like, you're not going to be able to go to the corner station. You're going to have to drive across town to get gas.
Yeah.
And I think that that's going to get increasingly inconvenient. So I have to say that I do think about that. It's something that I think that the day of the old classic car is sort of, as we know it today, that its time is somewhat finite.
It's waning. Yeah.
So I do think about it, but as so far, electrification is an option that I have not considered. It's so important to me to have the sound of the motor and the torque curve, and for it to feel the way that it feels. I don't really care about the looks. It's really about how it feels when you drive
8 seconds, that kind of thing.
8 seconds. 8 seconds. We're talking about 15 20 seconds. Yeah.
Well, yeah.
This concept of originalness, is that a word? Original, like, where these vintage, original, enthusiasts of these vintage products, want the authenticity. This doesn't just apply to mechanical, it applies to electronics as well. A lot of vintage computer enthusiasts won't accept any modern chip substitutes for, if their 74 LS00 chip dies or whatever, they want a 1970s date coded one to go in there to actually replace it. And I've got this as well with my Sinclair C5, which is a vintage 19 what is it? 30 years old now, right? So it's vintage.
The death trap bicycle.
It's an electric car, thank you very much.
Yeah, sure it is. It's got pedals, Dave. He's got a bicycle.
Sir Clive.
Yeah.
And one of the big things is, do you maintain the original motor, or do you put a new modern hub motor in the front? Well, a lot of people say, putting a hub motor in the front, that's sacrilege. How dare you? You've got to use the old crappy rear, 100-watt motor when, that's the only authentic way to run a Sinclair C5. Right. How dare you, sir?
Yeah, I used to be in vintage pianos. I was very much like that too.
Right.
Very. It's a dumb argument, from my opinion. Like, looking back on it now, it's like, I used to lust after these original kits, and it's like,
right. No,
it sounds the same. It's easier to maintain.
I hate to say it, but a lot of these vintage stuff, they will die out not because of push of modern technology, is because the people interested in them will literally die out.
Yeah, right.
They will literally die. Like, once, like in 30 years' time, who's going to care about a 1980s vintage computer? Nobody. Right. Maybe they might last another 30.
I think there will be specific examples, though.
There will be specific examples, like an Apple I, for example.
Yeah, the
but
C64 might stick around, or like the
but no, in general, the people who have the reason you have an interest in these generally is because you had it when you were a kid.
That's right.
It's the reason I love vintage computers, because I had them when I was a kid. That's why I don't like Valve, right? Like, people say, Dave, why don't you do videos on vintage Valve stuff? It's because I never was brought up on valves. I don't care about valves. Yeah. I have no interest in valves.
Valves, the tubes is another thing there instead of
tubes,
not the company.
Tubes,
tubes,
tubes, mate. Yep.
Right. So, I think in the auto industry, you see where cars get really expensive and then they get cheap again, and I think part of that is that there is sort of, people want the car that they always wanted when they were a kid, or the car that they had when they were in high school or whatever.
I rule.
And then those guys eventually are not driving anymore, and so then those cars are not worth as much. And I think the auto collector, industry, I don't know, the auto collectors have seen this happen to various generations of cars, through the ages. But yeah, I think things are certainly changing. You've got anything with an electrolytic capacitor from the 80s is probably on borrowed time at this point. And
I wonder if there's like subgroups that are like, oh no, I want to use my Motorola Razr phone, or I really the Samsung S6 is really where it was at, so I'm going to keep that for 50 years. Like, okay, good luck with that.
But literally, those ones you can't use anymore because they're removing 3G's going to go.
Sure,
yeah, that's right.
You could maybe
they've already got rid of 2G.
analog televisions. You can't use your analog television anymore unless you create your own transmitter. Which
I think that's what it comes. Yeah, and that's kind of like what you have to do. Like, even for you could have GSM service, right? You could do that yourself, but you have to be the tower at that point, and then
right.
What are you really doing here?
So, what year was your 8753 made, Chris?
It was made in 1996, which was before I was in high school.
Oh.
Jeez, that's not that long ago. 96. Jeez, I started working in the late 80s.
Dave, that was 23 years ago, Dave.
Yeah, still, that's
soon to
not
be
much.
24.
Does it have electrolytic capacity?
On my mailbag video yesterday, we're talking about vintage tech scopes and how there's the Yahoo.
Yeah, I saw that. Yeah.
Well, there was the Yahoo group. Now Yahoo's just shut down. Right, Yahoo groups is gone. All those Yahoo groups, they're now officially they're just gone. So that group, instead of die, they moved over to Groups.io, I think it is. But they've got thousands of vintage tech enthusiasts. But if you still think people are going to care about vintage tech scopes in 30 to 50 years' time, you're kidding yourself. No one's going to give a rat's
Tom Lee's going to go down with the ship, I think. But
you'll have these crusty 100-year-olds going, I'm still here's my vintage tech scope. Yeah. And I'm still answering questions on the forum to the two other 100-year-old people that are, still.
Yeah, I mean, it's a good question. I mean, like, I think the other thing is that, like, a lot of this technology, like, some of this stuff is just so early on, it was actually maintainable, right? Like a tech scope is still maintainable even without super original parts, but like, I don't know.
No,
so like,
because they rolled a lot of their own chips.
Oh, that's true.
A lot of custom chips. So you have to salvage
you have to
gear to get the chips.
Get the old chips out. Yeah, that's a good point.
Yeah.
But I mean, maybe like if we went to a simpler thing than even a scope, like we go to like a
you can get
vintage
simple
amplifier,
scopes.
like a vintage
a
guitar
vintage amplifier that uses BJT transistors and
or like valves or tubes. Like that. Yeah. That's another thing where those are simple devices. You can find tubes, you can find components. It's
you can
possible
still
to
buy
those.
your 2N 3051, and you can still buy your your 555 timers, and you can still buy your
You may have to wait a few months for the lead times, though. I feel
you
like
can buy them somewhere.
I feel like 2019 was the year of the long lead on through-hole components for me, at least. Because
really?
Yeah, because I still buy a lot of through-hole components for the kits. And
of course.
This was the first year when I had several components that had like 3-month lead times.
What specific components are we talking about?
Well,
were they
a quarter watt resistor.
A quarter watt?
Yeah.
Come on, a quarter watt resistor?
Yeah.
Like a special value or just like a 1K?
No, like 330 ohms or something like that.
Oh, man.
Like
what? A quarter watt 330 ohms?
Months of lead time. Ceramic
can you just buy
resonators.
stock kind of thing too.
It is absolutely the case that I could have just ordered a different part, but I could wait. I could afford to wait in this case. And so I was like, okay, fine. We'll see what happens. Because a lot of times, I don't know if you guys have witnessed this, but the lead times that are on the websites are usually completely wrong in practice.
Right.
Like they're a starting point. And a lot of times the parts will actually arrive much faster.
You gotta unmothball the factory. You gotta find all the the workers.
Start up the production line again.
Yeah, right.
Yeah. So this was the year of waiting months and months for parts for me. I placed an order for Geiger counter parts at the end of the summer, and I'm still waiting for the last couple parts.
Ouch.
Yeah. And I'm lucky that I sort of buy ahead, so I'm not out of anything. But I sort of buy with the knowledge that it may take a quarter to actually get the parts, and that's a new problem. I feel like prior to this year, I've experienced that more than once this year. And I think in previous years, sometimes there was like one component that was back ordered and it would be in stock in a couple weeks or something like that. This is the year. So do you guys think that through-hole components are going to become hard to find?
No.
When do you think that's going to happen?
No.
Well,
there's still a thing.
There's still a thing,
how
but
much longer?
What are you talking about here, too? Are you talking about?
I'm going to say the foreseeable future.
So 50 years from now, we're going to have through-hole parts?
No, it's not years, it's decades. It's decades.
Huh.
I don't know. Sorry, through-hole's just going to be a thing. You go buy still any modern consumer product, the power supply in there, through-hole parts.
It's a phenolic board,
Single layer phenolic PCB with through-hole parts. It is still a thing. It ain't going anywhere.
Well, it is true. I was trying to design a 350 volt power supply recently, and I looked at surface mount. That's a pain in the butt.
Yeah.
Well, especially
Devices
you've
are
got to
those
get those smaller
long
too, right?
extended packages. You know,
So
you got to get
trying
the
to
special
find-
long ones.
Yeah, like a voltage rating for like a
no.
0603 resistor is not that high. I can't remember what it is off the top of my head, but they're not that high. You know, maybe 100 or
It's
two.
about 300 volts.
Okay, yeah. So
the
doing
the
anything
future
over
we're moving
300 is
forward
hard.
towards is like everything is either 0201 or through hole.
01005
That's
or
all you
like
get,
quarter
yeah.
watt resistors.
Yeah.
And
You're
they've
either
got
making an
3 month lead
iPhone or you're
times.
making a power supply for a TV. Those are the two things you can make.
A garage door opener.
That's right. Yeah.
No, you can't beat a good old bulk carbon through-hole resistor in a 1-inch lead spacing. You know, that's
We need to like task Scotty to go find one of these factories. That they probably that factory's got to keep getting pushed out and out and out, right? I mean, everything gets pushed out in Shenzhen and everywhere else, right? But like where the hell are those? Are they still getting made?
Through hole resistor
yeah, of course,
factories.
they're still being made. The market, as I said, the market is huge.
But I
when
mean,
you've
like-
got consumer white goods that still use all these through-hole parts.
So,
It's
I
a
want to know where they're
massive
made.
industry.
All right, we're gonna ping him right after this. We're gonna put Scotty on the case. So, or Jeff,
Niche
if you're not
episode
doing
just
anything,
for
you can go
us.
to China too. Whatever. You know?
Go to way interior China somewhere
right.
and try to
right.
find the Yageo factory.
Right.
Yeah. Wasn't there a buyout recently? Somebody, or was that Connectors? That was
That was right. Yeah, that we talked about that 2 weeks ago.
Oh, did we?
Yeah, they
Okay.
bought out.
Marvel's.
Kemet.
Marvel's. Yep. Oh, yeah, no, Kemet. Oh, that was right. That's further down. Yeah. Well.
Whatever.
We've done an hour and 20.
Yeah,
think we
we
should
should
call it
probably
quits.
cut it off.
Yep.
Jeff, where can people find
It's
you
another
until
year.
the next Keyzermas rings in 2020?
People can find me on Twitter as Mighty Ohm, at my website, mightyohm.com, Instagram, Mighty Ohm. When in doubt, Mighty Ohm will probably lead you to me. But I still have a blog in 2019, still have a blog at mightyohm.com, still selling kits on mightyohm.com. And yeah, that's probably the best way. But thanks for having me on the show. This is fun, as always. It is a lot of fun to be on the show and to talk to you guys.
Was it a decade ago? Have we been doing this show a decade, Chris?
Not yet. We're pushing towards
Not
August.
yet. We're pushing close. August. Okay.
Yeah, so
August
our
of
decade mark
2020.
Our
Wow.
decade mark with Jeff will probably be, I think, you were on one of the early
it
shows.
would have been a couple of months
15
in.
shows.
One of the early ones.
Yeah, I'd say
Yeah.
by 2021, I think we're at the 10-year mark with Jeff.
Right.
So.
Yep.
Yeah. We do have a category which we'll also share of all the Mighty Ohm appearances. So we'll, if people want to
Over the
join in
last
for that.
decade.
Yep.
That's the decade gone, folks. That's the
That's right.
teens. Does it have a? Is it the
The
teens?
aughts. No. I guess aughts is the O's.
No,
I guess the teens. Yeah.
It's the teens we call it, do we?
Yeah,
I don't know. I just don't. The 2010s is what I kind of call it. Anyway, that's over. Now we're going into the roaring 20s.
It's
The
a
roaring
wrap.
20s.
Yeah,
as they.
We'll have one
gonna
more
be
show
fun.
before 2020, I think. But yeah, we'll see you guys in 2020.
Cool.
Catch you next time.
Yeah,
Catch
thanks.
you next decade. It's good stuff. I think we've lost Chris though. Chris is gone.
Oh, no.
Yep.
Poor Chris.
His lips are
No, I'm
grey.
here.
His lips are grey.
Well, I'm
As
here.
we say, if when you use mumble and somebody's died, no, he's here. He can hear us. He can hear us. We're getting this robotic voice. So Chris's
Maybe
voice.
he's the ghost of Christmas past.
Here we go.
Christmas. The ghost of Christmas past.
Okay, Chris, we've got you. If you can say something, if you can type something, it should hear you.
Yeah, rattle some chains or, He says don't try to make this not Keyzermas. Okay, well, I guess
Oh, dear.
you're You're not a part of the conversation, Chris. This is our show now.
We can anchor this. No worries. We're our hour's up anyway, but so EMC, yes, very important. So I hope
How about
to do
now?
some
Can you
more
guys hear me
stuff.
now?
Oh, he's back.
Yes,
He's back.
you're
All
back.
right, fine.
Ooh.